let's talk about infinite limits. So when we talk about infinite limits, it's helpful to kind of look at them from the left, from the right, and then from two sides. Okay, so we write the limit as x approaches a from the negative side. That's how we get it from the left. And you're going to have an infinite limit of f of x. You're going to have an infinite limit if you get either plus or minus infinity. Let's draw a couple pictures to get the idea. So I'm going to draw a couple of graphs. Here's one graph. Let's label the A there. Here's another graph. Let's label the A here like this. Let me draw my function in blue. So you're going to have this coming all the way up, and that's going to be y equal to f of x, or you could have it come all the way down like this. This is also y equal to f of x like that. And what you can see is that in both cases, we're coming from the left side of A. For the picture on the left, your function is getting bigger and bigger as you approach to A, so that would be the positive infinity case. On the picture on the right, as we come from the left, your function's getting smaller and smaller and smaller, or more and more negative, so that's the negative infinity case. Okay. I could talk about infinite limits coming from the right, and when we talk about coming from the right, we would write the limit as x approaches a from the positive side of f of x. And we're going to call it an infinite limit if you get, again, plus or minus infinity. So let me reproduce a couple of pictures here. So again, this one is coming. We got one picture like this. We got another picture like this. Let me draw my functions in blue again. So remember, I'm coming from the right this time. So we're coming up like this, or we're going down like this. The key idea is that in both cases, we're approaching from the left side. This is the positive infinity case, and this is the negative infinity case. All right. Finally, we have two-sided limits, two-sided infinite limits. How do I express something that's coming from two sides? Well, I just don't put a plus or a minus. I put the limit as x approaches a. I don't write any plus or minus, and then I just put f of x. And that's going to be plus or minus infinity. So let me draw a few more pictures over here. So let's draw one picture like this. Let's draw the other picture like this. If it's going to positive infinity, when you come from the left, it should shoot up to positive infinity. When you come from the right, it should also shoot up to positive infinity. For the negative infinity case, when you come from the left, it goes down to negative infinity. When you come from the right, it also goes down to negative infinity. When those guys match up, then we say that the limit exists and it's either positive infinity or negative infinity. So you could look at this picture and you could see this third picture right here is sort of these two pictures joined together. And the second picture here is these two pictures kind of joined together. If you mixed this picture with this picture, you have a different scenario, and that's captured in our next example. So let's take a look at example 5. When I take a look at example 5, if I approach my function as x approaches 0 from the negative side, where does it look like my function is going? It looks like my function is going to negative infinity. So I'm going to put this is equal to negative infinity. When I come from the right side, as x approaches 0 from the right side, where does it look like my function's going? oh, that looks like it's going to positive infinity. So let's put this is equal to plus infinity. And what happens when x approaches 0? Well, x approaches 0 means you have to come from the left and from the right. And you want to make sure that you get the same answer. Now, in this case, when I come from the left, I got negative infinity. When I come from the right, I get positive infinity. So we're going to say that because those numbers are different, this limit does not exist. And I'll put a comment here. This is since the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. Okay? So the limits must be equal in order for the limit to exist. Must be equal in order for the limit to exist. Okay, maybe I should specify the one-sided limits. So that's really the point of this example. Just to emphasize one more time, the two one-sided limits exist, but the limit overall does not exist because the two one-sided limits are different. Okay, so a natural question to ask is, how do you know when you have an infinite limit? And that's a great question. In general, we have limits, or we have infinite limits when the denominator is equal to 0 and the numerator is not equal to 0 near a. So in the future, we are going to look at a lot of situations where the denominator is equal to 0. And what we're going to see is sometimes we can use certain mathematical, tricks to cancel that 0 in the denominator. But when we cannot do that, that's when you have the numerator not being equal to 0 near a, then you're going to end up with an infinite limit. Okay, so we are going to work on example 6 together in class, and then we'll look at when you have an infinite limit and when you do not have an infinite limit. What I want to conclude this video with is I want to conclude this with a discussion about vertical asymptotes. So how do you know when you have a vertical asymptote? Well, there's 3 different cases. The first case is the limit as x approaches a from the positive side of f of x is equal to any kind of infinity, plus or minus infinity. The second situation is when the limit as x approaches a from the negative side of f of x is some type of infinity, plus or minus infinity. And the third case, as you could probably guess, is the limit as x approaches a from both sides of f of x is equal to plus or minus infinity. Okay, so these 3 situations pretty much correspond to the situations that we described earlier on this lecture note worksheet. So x equal to a is a vertical asymptote. When we say that, I just want to emphasize a vertical asymptote is a vertical line. And vertical lines generally have the form x equal to some number. We're calling it a in this particular case, but you could specify a to be like x equal to 2, something like that. All right. All right, folks, we'll look at examples in class and then do some classwork. Take care.